Hey, how's it going, Calc Peeps? Welcome back. This video is going to cover 7.3 day 4. We've now done really 3 different days of volumes. What's new today is we're going to create our volumes by revolving around horizontal lines that are not the x-axis. So for the most part, this should be just like revolving around the x-axis with some slight differences. This first example, we're going to find the volume when we revolve the region formed by these two functions around the line y equals -1. I've already gone ahead, and I would like you each time to come up with a good sketch when you go to revolve. What I would like you to add is whatever you're revolving around. So I'm going to put y equals 1 right about down here. I'm really just looking for a rough sketch of this. Just like we did when we were making the 3D shape by revolving around other lines, we're going to try to give some perspective to this by starting by reflecting it. So I'm going to take this region that we're looking for and I'm going to reflect it over this line. So let's see, that would give me a point right about here. And then I have this other key point, so I have about that distance. Let's see, so I'm going to bring that, would take us right about here. We have a straight line connecting those. And then we have really this parabola region. And I'm going to switch the color back to red. And to give some perspective to it, it looks like we're going to have this kind of hollow region in between, and then we have a solid outer, which again is going to revolve around. That makes it a washer problem. The circles should be centered on whatever we're revolving around, which is right here. So I have a representative hollow circle, the inside of a washer right here, followed by right on the outside of that we have really a solid circle right about here. So there's our washer. And in all the other problems we've been reflecting down when we went over the x-axis. We did the same thing here. So I think it is best if we go ahead and add a radius, draw the radius by going up from the center of our circle, which is right here. So here's an example one. Here's the radius of the inner. And then we have the radius of one of the outer circles. And just like any other washer problem, to find just the area of one single washer, we would do pi r squared minus pi r squared. So I think what I'm going to do is call this outer one r sub 1, and I'll call this radius r sub 2. So the key to this, since the formula only is based on the radius, is figuring out what each radius is here. Let's start with maybe the r sub 1. The key thing to remember is that a function, or a y value, by definition starts at the x-axis. So here's my x-axis right here. So if I just call my radius y, that would only be this part right here. So the 4 minus x squared only takes us from here to here, and you can tell by the drawing that our radius needs to be this whole amount. The good news for this one is that we do know the distance between the x-axis and this green line down here, because that line is just y equals -1. So we know that this distance here is 1. So my whole radius, what I'm going to call r sub 1 over here, is this 4 minus x squared, and then we need to add 1 to it. And then I can simplify it to just call it 5 minus x squared. Okay, I'm going to switch up the color here, maybe bright green. Let's take a look at r sub 2. Exactly the same thing happens. If we use the function 2 minus x, that only gives us the amount from the line down to the x-axis, so that's this tiny bit of green here. And then the full r sub 2 also includes this part, which again, the distance from the x-axis to this horizontal line is just a 1. So our r sub 2 is the line 2 minus x, and then add 1 to it again. So we get a 3 minus x. So overall, when we go to write our volume here, it's going to be pi r squared minus pi r squared like the rest, so I'm going to move the pi in front. Our outer radius, that's the r sub 1 here, That's 5 minus x squared. It's the radius squared, of course. Subtract this other radius squared, 3 minus x squared. Let's keep our notation straight. After all that, we are going to integrate with respect to x. So the only part missing is our limits. The limits, again, if we're summing up a bunch of circles going this way, and we're using x's here, we need to go from whatever this x value is to whatever this x value is. So just somewhere on our paper we need to show that we're finding those values. So we do 4 minus x squared, set it equal. To find an intersect, you set those two functions equal to each other. I'm going to skip showing you that part on the calculator. We've done enough of this. Come up with a graph, use that intersect command. If we do that correctly, we would end up getting a -1 and a 2. So those would our limits end up being. And I think let's pull up the calculator here real quick. Try to keep this so that you can see it on the screen here. I'm going to store 5 minus x squared. Down below I'm going to do 3 minus x. Those were the two radii. And then on the home screen, we'll go to Math 9. And the reason I type those in y1 and y2 is since we're going to square each one when I go to variables, y variables, we don't need to worry about parentheses here. I'll just do y1 squared minus y sub 2 squared, comma, we're using x's here, comma, our lower limit is a -1, comma, our upper limit is a 2. Hit enter, we get 30.6, which is going to be a nice fraction, so we hit math fract, 153 over 5. Of course, one of the things often forgotten, I did not type pi in at all. It was right here. Some students will forget to write the pi. Just don't forget that part. So we get volume equals 153 over 5 pi. So that's it on example 1. There is another possibility, which we'll call example 2. It's exactly, the way I've set this up, it's exactly the same two curves, so the region is still exactly the same. This time we're going to revolve around the line y equals 4 instead. So really for the first time what we're going to revolve around is actually up above, and 4 is right here. So the line we're going to revolve around is this place right here, y equals 4. So this time, really for the first time, to get our 3D shape, we're going to be reflecting over, or up. So that key point that was right here, since this is our region, I'm going to place that key point about right here. I think I want to go back to red. And then here's this other key point, so if we place that right about here, on our drawing that we're reflecting, we have this line, and then we have the parabola piece, which would go down and touch right about here and come up. So first of all, this is kind of a cool shape in that we have some hollow pieces here and here, and then in the very center it looks like it is completely solid. The math should take care of that for us though. So one representative circle we could have is, it looks like we have a hollow circle here and then an outer circle here. So it's a washer problem again. What should happen is if we set it up properly, when we're right here, there shouldn't be, or the radius of the center circle should be 0, where we would still have some sort of outer circle. Now one of the key things that makes it way easier, I believe, to visualize this, to come up with good radii is that anytime that you find yourself drawing the 3D shape by reflecting up, it usually is easiest to visualize a radius by drawing it going down. So our two radiuses that I'm going to draw this time, again, should be centered on the line that we revolved around, in this case y equals 4. Looks like we have an r sub 1 right there, so notice I drew it down. And then the hollow part, which over here there'd be a hollow circle, would go from right here to something like right there. So an r sub 2. Okay, so let's try to figure out what expressions would represent each radius there. Washer problem again, so at the end of the day our volume is going to be pi r squared minus pi r squared, so that simplifies things a little bit for us. Okay, again what I'm going to start with is I always need to do measurements from an axis. So if our x-axis is here, when I look at r sub 1, it looks like with this long radius here that we have from the x-axis, we have this part right here is a y value because it goes from the x-axis till we hit the line 2 minus x. And then this time the thing we also know is from the x-axis to this, we know is a distance of 4, since this is at y equals 4. So this leftover r sub 1 is the full amount of 4, and this time I need to subtract out this little piece, which again is the 2 minus x. So 4, I need to subtract out that little bit for the line, which is 2 minus x. So it looks like we get 4 minus 2 plus x, which would be a 2 plus x. So this amount here is 2 plus x, no matter where we're at. And something very similar happens for r sub 2. We want to measure things from the x-axis. So right here, that goes from the x-axis till we hit the parabola. So this part would be the equation of the parabola, 4 minus x squared. We'll use this 4 that we had before. So again, we'll know this full amount is 4. So to find this little tiny radius here, we need to be 4. We need to subtract out this parabola piece of 4 minus x squared. So r sub 2 should equal 4 minus r squared. This time we get 4 minus 4. Looks like we end up with just an x squared. And just to check it a little bit, we can always throw in some x values to make sure it seems to make sense what our values are. I had mentioned before that our inner radius should be 0 because there is no hollow part right here at x equals 0, and sure enough, if we put an x equals 0 in, we get a radius of 0 here. So that makes sense. And then we could keep trying values. If we're out here at what we know is x equals 2 from the earlier part, and here's x equals negative 1. At 2, it looks like our radius, the hollow part, should be the full amount. And sure enough, if we throw a 2 in, we get a 4. So our inner radius is actually this full amount of 4 here. Okay, our volume, it's a washer problem, so pi. Our region still went from negative 1 to 2, so there's no new work to do for that part. And we'll just take our outer radius squared, because it's pi r squared, minus another pi r squared. Get our notation correct. Okay, so that's most of the work. We'll continue to use our calculators for this. I'm just going to change, let's see, the outer radius this time is 2 minus x. So let's delete that. And then down here, our inner radius is just an x squared. When I go back to the home screen, I'll hit second enter. And I'll hit second enter again, and I think I don't need to change the statement the way I did that, because then on the screen here we have outer radius squared minus inner radius squared, and we're still going from negative 1 to 2.4, which again is a nice fraction. It's 12 over 5. So volume equals 12 over 5. Don't forget the pi. Alright, so there's two examples where we're revolving around other horizontal lines that aren't the x-axis. Then we'll do one more day, day 5, where we'll revolve around other vertical lines other than the y-axis. Good luck on this assignment. Please come in with any questions you have. I'll see you guys real soon. Bye bye, take care.